Hello everyone, myself Dr. A.Richard PRAVEENDOSS, Assistant Professor of Mathematics, St.Joseph College of Arts and Science, Cuddalore. Now I like to share something about Laplace transform. Why we use Laplace transform? We are going to find solution to differential equation using algebra. Relationship to Fourier transform allows easy way to characterize systems. No need for convolution of input and differential equation solution. Useful with multiple processing system. We are going to see how to use Laplace transform. We need to find differential equation which describe the system. And obtaining Laplace transform, perform algebra to solve for output or variable of interest. Applying inverse transform to find solution. What are Laplace transform? Laplace transform is denoted by L of f of t, which is equal to f of s, by calculating the equation integral 0 to infinity f of t e power minus st dt. For finding inverse Laplace, it is denoted by L inverse of f of s, which is equal to f of t, with the equation 1 by 2 pi I integral alpha equal to I infinity minus I infinity to plus I infinity f of s e power I e power st ds, where t is real and s is complex. Inverse requires complex analysis to solve. Transform is a function f of t to f of s, where t is integrated and s is a variable. Conversely, if a function is from f of s to f of t, t considered to be a variable and s is integral. If assume f of t equal to 0 for all t less than 0, evaluating f of s, which is equal to L of f of t. It is very hard way for the integral. Now with some example we can exhibit f of t, that is Laplace transform of f of t. Now consider a function f of t equal to 1 with the equation f of s equal to 0 to infinity e power minus st dt, which will give the result 1 over s. By seeing second example, which is considered as f of t equal to e power minus at, and with the equation 0 to infinity e power minus at with the multiple of Laplace integral e power minus st dt, and combining the values, since the basis of the given function is same, we are combining the value with the exponent law e power minus of s plus a multiple of t into dt, which will give you 1 over s plus a. Next example, seeing Laplace transform of sin t. Now Laplace transform is denoted as f of s equal to 0 to infinity e power minus st dt. While applying the function sin t, we can use integration by parts. We already know the value of integral u dv equal to uv minus integral v du. Now considering e power minus st as u, differentiating e power minus st, we get minus s e power minus st dt, and dv equal to sin t dt. While integrating sin t, we get minus cos t. Applying in the integral, we get the result as 1 over 1 plus a square. Why we are using this Laplace transform? Because this is the easy way for integral calculation, and we can recognize different transforms, and we can learn few different properties. Now the examples of the Laplace transform: f of t equal to Laplace of t equal to 1 over s. Now shifting property: e power minus at f of t equal to 1 over s plus a. Then Laplace of cos t equal to s over s square plus 1, and sin t equal to 1 over s square plus 1. Some more transformation: Laplace of t power n equals to n factorial over s power n plus 1. By applying the various values of n, we get the results. Next, step function. Now unit step function is defined as 1 when t is greater than or equal to 0, 0 when t is less than 0. Used in conjunction, the function is from f of t to f of t u of t. The limits of Laplace is considered to be 0 to infinity. We already know the Laplace transform of L of f of t equal to 0 to infinity f of t power minus st dt. Some of the properties of Laplace transform: linear property, then scaling property, shifting property, then all other using integration and differentiation. Now linear property of Laplace transform is denoted as L of C1 of f1 of t plus C2 of f2 of t, which equals to C1 of f1 of s plus C2 of f2 of s. The proof of the linear property is given with the example of sin ht. Now sin ht is considered to be e power t. Now applying Laplace transform e power t minus e power minus t over 2, applying Laplace transform, we get the result for sin ht as 1 over s square minus 1. Then scaling property: Laplace of f of at equal to 1 over a f of s over a, and it is illustrated with the example of sin omega t. Next, shifting property. Shifting property: when we use e power st f of t dt, the shifting will be increased to s to the shifting is increased from the origin to the given power. Now here in this example, e power minus a t minus 10 u of t minus 10 will give you e power minus 10s over s plus a. Thank you.